Okay. So the first couple chapters, they look at the process, they talk about the measurements, they talk about different things in the introduction. And then when we get to chapter 3, we really get into the measure, and chapter 4 is about the analyze. So I'm going to talk a little bit about what this looks like. And I actually ran through these. And so some of the things we talked about before this, I've got examples of in here, so I didn't have to bring in extra ones, which is a good thing when it happens like that. So we're going to measure this process that we're trying to improve. So we want to understand where we are. We want to get a baseline. So the baseline says, what is the current situation? And then we say, okay, because we want to improve that situation. Now, how do we get that to the next level? And we might have goals given to us from the management team, from the sponsor, from the champion, who says, this is what we're going to do. And we need to improve the productivity here. We need to do this with fewer resources. We need to cut some costs. We need to cut some time. Whatever the challenge is that we've been given, we're going to figure out what are the things that about the process that we can measure. So what we're trying to do is to find the truth in how the process works. So one of the first things to do is to really look at the process and then understand what does the business think is happening here, or what does the process say is supposed to be done, and then what's actually being done. How many of you have like manuals where you work that tell you how to do something? You've seen that? So processes. So all of that documentation is done for a reason, to teach you so that you can all do the same thing the same way, right? But when we look at some of these processes and we want to try to lean them out, we want to say, okay, what are we supposed to be doing? So then you pull out the process, and time after time when I've done this, you pull out the process and you find out that, one, nobody's looked at it in a year and a half or more, and it wasn't updated since maybe 1969 or something. Sometimes maybe not that bad, but it hasn't been updated in a while. And that maybe what we're doing is not what's in that process. So you want to understand what is documented, what is that is maybe supposed to be happening out there, or at one time was the standard or the accepted methodology used. Then you say, okay, we look at that now, and you can take two people to do this simultaneously, or two groups of people. So a couple of you go over here and document the process from the documentation, and then a couple of you go over here and actually watch people doing that process and write down what steps they're taking. And then you get back together and you compare and you say, oh, look at this. We saw this being done on somebody actually doing the process, but this process as written is a little different. So where are the discrepancies, and what is the right way and the best way to do it? Sometimes the documented process has things in it that get lost and could be beneficial, and sometimes they get left in the drawer because it's not the best way to do that. And a better way to do that is actually what's being done on the line. The other thing to consider is, how many places is this being done? So if you have more than one production line, you want to document a couple of them and see how, if you have the bandwidth, document each production line and see what's being done on each line. It might be the same, it might be similar, and it might be that there's some very glaring differences in how the different production lines are accomplishing basically the same task. But it's important to get that documented. And while you're doing that, you want to say, how well is this process working? So what are the defects that are on this line? And I talk about it in production line because that's sometimes the easiest to envision, that you're putting things together, you're taking these three raw materials and fitting them together, gluing them snap them together, whatever, and then sending it down to the next station to put something else on, like you put a phone together or a computer together. But it doesn't always have to be production lines. It can be invoice processing. It can be purchase order creation or requisition creating, or any number of things that you do, any kind of like a paper process. And when I say paper, it doesn't have to have paper. It can be a paperless process that just has steps to be done. How do we, like I say, how do we create a purchase order? How do we create a requisition? How do we create a specification if you're in a design area? How do we create that drawing, and then how do we document that and get that finalized and approved and all that? So sometimes there's approval processes that go along with that, and lots of other things.
I have a question.
Go ahead, Tony.
So what kind of time frame are we talking about doing this? Because one thing I got from the reading, and I'm seeing from this, is you're talking about things that take forever, that literally, to me, take forever, and then nothing gets. And what I see happens is that halfway through it, people just give up and it never goes anywhere. And so you're then working against the principle of lean, where you're just wasted a whole bunch of time.
Right. So what I find is that if that happens, then the problem or the goal probably wasn't well defined to begin with, and it allows people to kind of go in too many directions. It may take some time, but the more complex problems will take longer than, than something that has a little bit simpler. But it shouldn't, if it's a Kaizen, it's going to be very short. We can go in and we can knock this out in a day or two. If it's a green belt project, it's probably going to take a few weeks to do that.
And then what size companies are we talking about here?
Any size. It can be a really small company. I worked with a company here in Los Angeles that makes cables. So they take wires, they cut wires, they put some connectors on them, and then they bundle them up, kind of thing. It's some simple processes. And then of course they have some pretty complex wire harnesses, but it can be any kind of, process like that. Like I say, it can be a kind of a service thing. It could be like medical billing. You could lean out the medical billing process in a doctor's office or dentist's office. It could be a scheduling kind of thing in an office, like a law office. How do we schedule people? How do we get things done that way? So it can be a lot of different things other than just how do we make something. But the lean processes, and to lean it out, usually I would say give it a few weeks, a quarter of time to do it, because you're not necessarily doing it all day, every day. Most companies don't have enough people, right? I've never been in a company who says, gosh, we just have all the people that we could need. Every task that we would like to do, we have somebody that we can put on it. It just doesn't happen. So if we want to do this lean approach, we're going to have to take a group of people and we're going to have to dedicate them 10%, 20%, maybe 40% of their time for a certain amount. But that means they're going to have other work too. So they're going to be kind of bouncing back and forth to do that. That's why the Kaizen is nice, because then it's like, okay, we're going to take 1 day, 2 days, and that's all we're going to do. And people find they can, and managers find they can devote a day to do something quick on a Kaizen type thing. But on a lean project, I can't take my whole team and go work on that all day, every day for the next 6 weeks. But I can take somebody that's pretty good and have them work on it, 20% of the week. 20% of 40 hours is 8 hours a week, a couple hours a day, maybe. Yeah, you can do that, an hour a day. A lot of people, good people, can find that kind of time. And these are usually, they should be made to be an enjoyable project. It's not necessarily fun and games kind of thing, but it should be somewhere where you have some creativity, you have some flexibility, you are able to employ some skills you might not in your all day, everyday job, and try a few things different and take a different approach. So and this is where you need a really good champion or sponsor who keeps people on track and doesn't let it get to where you give up halfway in and say, you know, we just now wasted the last 6 weeks and we got nothing to show for it. If hopefully that doesn't happen. Now, it does happen occasionally that you pick the wrong project, or you find out that something is more broken than you realized, and then you have to take another approach to go do it. But generally, you want to just go find something that you're trying to do better. You're trying to improve, or trying to get rid of a pain point. Does that help?
Yeah.
Okay. So we're looking at documenting the process, what is being done, what is supposed to be done, and then, comparing those two. And then not only what is being done, but how is it working? So again, you go back to the documented process and say, what is supposed to be happening here? How is the result supposed to look and be? What's the outcome supposed to be? Maybe there's a rate on that this is designed to do 10 parts an hour, or it's only designed to do up to something, or it was only designed to do the pilot project and nobody actually got around to documenting the production process. So how is it working? And then compare the actual results with what the desired results are. This can go back to defining the problem and bounding the problem. Is we really need to get this line balanced, which means we need to have equal work amongst these 4 stations so that we can have this nice work flow through there. So we can't get enough work done in station 2. There's too much work. That's the bottleneck. And then in station 4, people are only working 2/3 of the time. So they've got a lot of free time. How do we shift work from one station to another, or break it up in a different manner? So what are the actual results and what are your desired results? And then what tools do we have to use? So we're going to look at some process maps and some value stream mapping here. So one of the processes that you use, and one of the tools, is what we call a SIPOC diagram. SIPOC stands for suppliers, inputs, processes, outputs, and customers. So then we say, okay, who are the suppliers? Again, bounded in this process. So we're going to look at this particular, maybe we have 5 steps in the process. We're going to look at step 2 and say, hey, that's where we're seeing the bottleneck. So let's start with step 2. So we say, okay, who are the suppliers to this process? The suppliers might be the production control people who bring parts there, somebody who brings the tools. It might be a really supplier who brings you like nuts and bolts and screws to that station or whatever. But who are the suppliers? And then what are the inputs? The inputs in terms of what's required and what's going into this station, this workstation, or this process that is supposed to enable us to produce whatever we're trying to produce at the end of it. So we look at the suppliers, the inputs, then we say, what is the process itself? What is the method? What are the steps that we're supposed to be using? Or what should the steps be to get the right output? So what are we trying to get out of this station? Are we trying to get a finished good, or are we trying to get a semi-finished part that we can take to the next station and paint or put something else together with, or test, or whatever? So look at these on an individual basis and write these things down. This happens to be some colored charts that are kind of interesting to use. And then finally, who are the customers? Who are the people that are getting something out of this? Sometimes it's the actual customer that's paying the bill. Sometimes the customer is maybe like the next station. Sometimes the customer is the quality department, or some department or the finance department that needs a result from this process that's going to be able to use that and, look at from their perspective. So who receives the output? What is their expectation? And what is their feedback on what's actually happening? Are they satisfied with what they're seeing, or is that something that they have raised the flag about and said that they aren't happy about it? And if they're not happy, why aren't they happy? What is the actual complaint? Not just, I don't like it, but what don't you like about it? So sometimes that requires a lot of customer interviews and things like that. So you want to define the process in terms of each of these aspects: the suppliers, the inputs, the process, the outputs, and the customers. So the way you create this, in this case, we're going to say, let's feed the dog. Okay, so this is a pretty simple example, and I've given you an example for the homework, I think, next week to do. So the suppliers, in this case, we're going to say the grocery store. Now we could say, all right, we could get this from the grocery store. If we're going to feed the dog, we can get dog food from the grocery store. We can get it from Instacart. We can get it from Amazon. We could do all of this. But what do we typically do? We go to the grocery store and get the supply and get that. And we could get 16 different brands, but that's not really what we're trying to define in this particular one. We're trying to say, okay, what can we do? What do we do? So what we do is go to the grocery store. The inputs to that are, we go shopping, we buy the dog food, we come home, we put the groceries away in the cupboard, we put the dog food in the bin, and there we go. Then when we're going to feed the dog, we actually get the dog food out of the cupboard. We get his bowl or her bowl, we fill it up, and we call the dog, or we just kind of shake the bowl. And if you're like the dogs I've had, when they hear the food go in the bowl, man, they come running. So you don't even have to call them, right? You just call them by filling the bowl. And then you say, okay, the outputs: the dog eats and the dog poops, right? He fertilizes the garden, or she does. And then the customers are the dog, the rest of the family, and the garden. Okay. So then we say, okay, who are the suppliers? Right now we go to the grocery store. Well, what else could we do? We could go to Petco. We could go order it on Amazon. We could feed the dog from the table scraps. We could get food from the vet. We could do this. We could do that. We could get 16, we could change the brand of food, or we could do lots of different things. The inputs then, instead of going shopping and buying it, we could have Instacart. We could have it delivered. We could, again, if we're going to get table scraps, we can get it from the food that we get for ourselves and do that. And then you go to the next step and say, okay, feed the dog. The process is to open the cupboard, get the bowl, fill the bowl. But if we're going to do this with table scraps, it might be a little different. If we're going to do this with any other dog food that we get, whether it's from Petco, Amazon, or the vet, it's probably going to be the same thing. Open the cupboard, get the bowl, fill the bowl. Unless you want to go to what I've seen on TV lately, which is go to the refrigerator or something like that and get the dog the fresh stuff, and however. Does this make sense? So this is a really simple example, but you can apply this to a lot of things. Then you say, okay, what are the outputs? The dog eating or not eating, that's pretty much the output, and that's what you want to have happen. You can come up with some different things and say, what else would be there? If we happen to live in a high rise, we might not have a garden for the dog to fertilize, so we have to figure out what else to do when the dog needs to go and relieve himself or herself. And then, what do we do with that kind of thing? That can be a whole different part of that. And then who are the customers? In this case, the dog, the family, the garden, the dog, the family, the sidewalk, or, whatever else we're looking at. So you just look at this, and it's good to do this more than once. You don't just look at this once and say, okay. You go back and you say, all right, when we talked about this before, we looked at these suppliers. Does anybody else have any other ideas? Is this all we have, all we can do? Does this what makes sense? Or somebody says, I thought about that. We talked about that Tuesday, but Thursday I thought about that, and maybe we could do this and this and this, because sometimes that iterative process works. You don't want to, as they say, beat the dead horse, but you do want to make sure that you get enough focus on it and you give some time to to let some creativity percolate in your brain and come up with some other ideas. So the value stream map really has several different components. You're looking at a map of what the processes are. So if we use the same example with the dog, we might draw a line from our house to the grocery store and back, where we may say, hey, we need to buy this in conjunction with buying the weekly groceries, and we always go on Thursday and buy the week's groceries. So let's put that in there and couple all that stuff together. Or even if we go to the pet store and buy it, that pet store is next to this, so we can buy it in terms of putting these kinds of activities together. So you want to look at what your process time is, what your lead time is. Process time is how long does it take you to perform that activity? How long does it take you to go to the grocery store? How long does it take you to go to the kitchen or to the pantry, get the dog food, bring it out, scoop it out into the bowl, and put it down for the dog to eat? And you can include things like cleaning the bowl out, washing it, whatever that you want to do before or after the dog eats, if that's important to you. Giving him or her fresh water at the same time you feed them, that kind of stuff. So you're looking to see what are we doing, and then what adds value to this. So the process time is how long does it take us to actually perform that. The lead time is from the time we are like ordering, how long till we get the receipt of what we're doing. So if you're doing an Instacart thing, okay, my lead time might be, I'm going to put my Instacart order in today and I'll get it tomorrow. Or maybe I can get it within, if I do it before noon, maybe I can get it by the end of the day. But I want to make sure that I order that food to have some on hand so that we don't run out, because the dog is going to get cranky if he doesn't get fed. Then what's the changeover and setup time? Is there a changeover, or is it just a constant thing? The changeover for feeding the dog might be washing the bowl out and making sure that you throw away anything that he didn't eat or she didn't finish from yesterday or from this morning when you're feeding them tonight. Is there any cleanup that needs to be done? A lot of dogs are sometimes drool and drip water and food and crumbs and things like that. If you feed them hard dog food, they crunch it, and you might need to clean up. So you might want to clean up the crumbs and the water spills from today before you go to bed, or before you feed, from this morning when you fed the dog to when you feed him tonight, if you're feeding them twice a day, or from yesterday if you're feeding them once a day. What is the demand rate? How much do you feed them? What is the capacity? When you look at capacity, we're looking at people, the different people skills involved, the space and the equipment. So, if you're making something complex, this can be pretty complex, but if maybe you're paying bills, maybe you're processing invoices. So you've got people that can review the invoices, check them, make sure everything's correct. And you can have 3 or 4 people doing that, but there's only one person in the office that's actually allowed to make that monetary transfer, right? To actually enact that money going from point A to point B. Or it might be that you have multiple people doing that. So some skills may be very unique, or the authorization may be very narrow. And then sometimes that you have a lot of highly skilled people. How much space do you need? Again, how much space do you need for the dog to eat? Is that in the way of something? Can you do something else? What equipment you need, and that kind of thing. And then the yield, how much do we get that's good? Once we start something, what's our output? Productivity, output versus as a ratio of the inputs, but also just if we start 100, do we finish 100? So if we start 100 and we're going to lose one somewhere along the way, that's typically what happens. If you're making cookies, if you put 100 cookies on a cookie sheet or on multiple cookie sheets, every once in a while, you're going to get one that's just not good, right? That it doesn't do what it's supposed to do. It has too many chocolate chips in it, or it didn't, maybe it got a little more butter than it should, or on the edge of the cookie sheet where it gets too hot and it got a little too burned for you to use or something like that. So you might say, I'm going to start 12 dozen cookies, but I'm only, of that 144, maybe I do 150 trying to get 144 good ones, because I usually lose 2 or 3 out of the batch, or I end up with too small a cookie at the end and I can't use that one. So what is my yield? If I put 150 cookies on cookie sheets, do I actually get 150 sellable cookies? And the answer is probably no. It's probably going to be, you're going to lose 1, 2, 3 or so, just because of lots of different factors. And then what's my inventory, and how does the inventory move through there? So we actually create a map, and I'll show you a little bit about that. So what do we measure? We're going to measure all kinds of things. We're going to look at it from the customer's perspective, which is the voice of the customer, which is something that we want to document. We're going to look at what things are critical to quality. Sometimes that's from a quality engineer or from an engineering perspective that says, if this is the most important, if I'm making this bottle, the most important thing in here is what? What do you think the most important thing in making these parts? So I've got a label. I don't know if you can see it or not. I've got a label, I've got a bottle, I've got a lid, and I've got water. And there was another label too on here, but it got peeled off. But what's the most important thing?
The water.
The water? Okay. What part of the water is the most important?
Safety.
So in terms of what would I measure? So this is supposed to have 500 milliliters or 16.9 ounces. Is the most important thing the amount of water, or like the quality of the water, the goodness of the water, the filtration system?
I would say the goodness is probably the most important thing.
Okay. So it might vary from thing to thing, right? But okay, if you think the water's the most important, then you're going to say, all right, we're going to check that. So that's the thing we're going to check every time. And that might be the most important component of this. But the most important thing in order to sell it might be that the lid actually fits on the bottom, right? So if these threads are bad for whatever reason, and I can't get the seal where I want it, then it might spill, it might evaporate, it might get contaminated, and that's going to be a problem. So from one design aspect, it says, make sure that the water is good, but I can check the water this often. And, you know, this is how I'm going to check the water. And then I also need to check the lid, and I need to check the threads on the lid and on the bottle, because they need to match up. I need to make sure that's fine. The rest of the bottle I need to check, but it's not critical, because if there's a little bubble in the bottle, and I don't see any, but if there is a little bubble, yeah, there's one there, or some little scratch or something like that, that's not going to hurt, right? But if I can't seat this lid the way it's supposed to seat and then turn it and get it sealed properly, then that's going to be a problem. So that's the aspect I want to check, and I want to make sure my mold is producing both bottles and lids to those right specifications. If I get a little fatter bottle than I wanted, that's not the worst thing. If I get you know, that if this lip or this dimension, this crown kind of thing around here is not exactly perfect, it's probably still going to be okay as long as I can fit the lid on there, right? So the designers, the engineers usually determine what is critical to the quality. Sometimes the marketing guys weigh in and say, hey, our customers are not going to buy it if it's not XYZ, right? So different aspects, but you define that. It's not every piece of this. Every piece of this is important, But there are 2 or 3 things that are really critical to me being able to meet my customer demand and get this passed and keep this going. So what is critical to the quality? What are the outcomes? What's the in-process things? And then what are some of the datas that I can calculate? So a gauge R&R just talks about repeatability and reliability. So there's some statistical tests you can do on that. We're going to do sampling plans. We're making millions of these bottles. We are not going to check every bottle that we make. We're going to check every 100 bottle that we make. So we're going to make 99 and check the 100 one, and then make 99 more and check that, or whatever my pattern is. What's my sampling plan? Again, think back to your statistics class and you set those up. What's my attributes? What things are attributes, like looking for little bubbles in the bottle or flaws in the label or the label not put on smoothly. Those are attribute things. And then what's variable that I'm going to have to measure something on. So we're looking at all those kinds of things. And then I throw in this thing because I'm a big Albert Einstein fan, and I don't know if he actually said this. This is one of those things that's often attributed to him. But I think that the whole idea here is brilliant, that not everything that can be counted counts, and not everything that counts can be counted. So sometimes we would like to measure, maybe we'd like to measure the inside diameter of this bottle. Now we can measure that, but it's harder to do that, right? Because you'd have to put something inside the bottle that would expand so that you could measure the inner diameter of that. So if that's really what we wanted to know, we might say, okay, but that's going to take X number of time per bottle, and that's not a good thing. What else might we do instead of doing that?
I use height and radius and measure volume, and maybe come up with the measurement that way.
Okay, so we might want to look at the height and maybe the width of the bottle, right? Because if that's the right dimension, then we're close. But if this wall is too thick, then I'm not going to have enough space inside for my water. So what else might we do?
You can just cut the top off the bottle and measure it.
Yeah, and what we can do is, when we're filling the bottle, we know how much liquid is going in, right? Because we have an automatic dispenser that's going to measure 500 milliliters, and then we're going to look and see where it hits on the bottle. So if it starts to hit up at the top, then we know that we don't have enough space in there. But if it hits between, 2 areas, and we could hold this up to a master and say, if it hits between here and here, it's all good, right? That means the inner diameter is going to be okay because it holds the water the way it's supposed to. So we have to look for things that we can do easily, readily, which is put 500 milliliters of water in it and see where it hits in the bottle. Now, if this was 500 milliliters of water, I'd be in trouble, because if I saw this with even a sealed cap, I'm not going to buy it because it's not full, right? It needs to be full. And if it's up to the top, it's going to be too full. And if it gets hot, or if it gets knocked around or something, it could spill and cause pressure and have a problem. So, from a visual, you want to be somewhere in here that's going to look like I'm buying a full product. I'm getting my money's worth of kind of things. So if you can't measure the ideal thing, what can you measure that is reflective of that, or is a correlation to that, or is an indication that whatever you'd like to measure is doing the right things, doing what it's supposed to do? Because oftentimes companies measure whatever's easy. Oh, we can measure that, so we're going to measure that. And they have no idea what's going on. It doesn't reflect the things that are critical. And so they can say, oh, my process looks really good. Look, I got these great charts. Everything's pretty on these charts, but you know what? The part at the end is a piece of crap. So you're not measuring the things that count. You're not trying to do that. And then finally, with analyze, we're going to look at the process flows and the process maps. And I think I have an example of those in here. We're going to do visual analysis, but we're also going to do some statistical analysis, and we're going to try to dig into the root cause analysis. So we're looking for the waste. So again, if we go back to finding the waste, look in the areas. We're going to look for transportation. Are we moving it too much, or are we not moving it enough where it should be moved more often and it's not getting like rotated or shaken or whatever? Where's the inventory building up? Is it the right levels of inventory? Do I have too much? Do I have too little? Motion. So this is where the book talks about this Tim Woods acronym. So transportation, inventory, motion is the TIM, and then waiting, overproducing, overprocessing, defects, and skill. So those are the things, and the book says this is the way to remember those is Tim Woods. If that helps you, that's great. If it doesn't, then it doesn't. But it's kind of a clever way to think about those and try to remember the wastes. So we're going to do the visual analysis. One thing we do is we chart things, right? We take measurements and then we make this. So this is a bar chart. Sometimes the bar charts show the biggest piece in the middle, so they resemble that normal curve, right? You guys have all seen bar charts like that with a big bar in the middle and then on either side of that. So that's fine. That shows the normal curve, and that's what it's designed to do, is to indicate that, yes, we do have a normal distribution here. But sometimes we want to do it, we want to look at it in a different way. And we use what we call a Pareto chart, which looks from biggest occurrences to lowest. So, and the Pareto principle is the idea that for the outcomes, 80% of the consequences are driven by 20% of the causes. Now, this is not an exact science. So if you can come up with 75 and 25, that's still kind of in that ballpark. But we call it the 80-20 rule, because for many things, like most of your defects, 80% of your defects will be of one kind, or they might come from one supplier, or they might be related to one product. So there's clusters of these things that happen naturally, just like the normal curve happens in nature. You don't have to force it. Many things have normal distributions. The Pareto principle says the biggest chunk of things is often 80% of the outcomes, and then that's driven by 20% of the causes. So if we did this, in this case, we're looking at the category, maybe these, and it could be that this is what we're looking at in terms of revenue. So we're saying customer B gives us this much revenue, and then customer F and G and whatever. Or it could be this is our number of defects, and this is the type of defect. They're type B defects, or the supplier that they come from, or the part that they're found in. So whatever it is, the idea is that we want to go concentrate in the area that's going to give us the biggest return on our investment. So Tony, you were saying that sometimes you work on things and it doesn't ever get resolved and it kind of just fades away. So the idea is that you pick these big bars, if they're in terms of like defects or problems, and you work on that, because that's going to get more notoriety, more focus, and that's going to make a bigger impact to your business than if you tried to look at E or D. So if these are my defects, I'm going to look at this and say, oh, most of my defects are type B. I would like to reduce this in half. So this is going to make a big dent in my total number of defects, right? If I look at how all these would add up. Conversely, if I said, I'm going to go eliminate D, then I might say, well, that's a good thing to do, but you know what? I'm not going to feel that at the end of the day. That's because most of my defects are right here in these first couple of types. So I really should be working on this and not on this. So my rule is always this. This is a good thing to look at and say, these are the problems that we have. If you can fix anything on the small bars, if you can fix them very quickly and for not much money, not much time, then do it. But if it's going to take a lot of resources, then put that off and go work on the bigger opportunities. So it says, oh, if I could just, you know, maybe D is the operator, and oh, that's Danny. He's the new guy and he hasn't really been trained. So we need to get him trained so he stops doing that defect. Amen. Let's go do that, right? We're going to do that. But if I'm guessing that this B is not that same kind of problem, it's going to be much tougher to do. So if we can fix things quickly and easily that are at the end, there's no sense in not doing that. But if I have to go dig into this and make this a bigger project, then I really want to put my energy on where I'm going to get the return on my investment, which is those big pain points or those big opportunities. So that's the Pareto principle. It's the 80-20 rule, and the Pareto chart just says we're going to chart it in this manner, which visually is going to tell us, go look at B and F, maybe G, but that's where our big bang for the buck is, in B and F. So here's some of these tools. Cause and effect diagrams are also called fishbone diagrams, and they're also called Taguchi diagrams. Is it Taguchi?
No, I think it's Kawasaki.
Kawasaki. Why don't I know what that is? I'm gonna have to look that up. Ishikawa.
Oh, that's it.
Ishikawa diagram. So that's kind of hard to remember. Obviously, I blanked it, but we call it a fishbone because it looks like the main backbone of the fish and then all of the little spines that come off of that. If you've ever flayed a fish open, or sometimes just eaten one, sometimes salmon is served with the bone in like that, and you can see the bones. So the idea here is you put the problem at the end, and then you start saying, what are the possible causes? So this is our effect, the quality problem. And then these are the things that drive that. So the way I was taught to do this is you look at the 4 M's, which are men or people, methods, which is the process, machines, which is any of the equipment, and then you look at material. So material, men, machines, and methods. So those are the 4 M's. Then you also add in the environment. And in this case, you could add in suppliers. So that's a good way to remember it. If you started with the 4 M's, you'd be in a good place to start with the people, the machines, the method, machines, the methodology, and the machine, methods, and materials. This has machines in there twice, so I don't know why they did that. Obviously, I stole these, scabbed these together. So that's the Ishikawa diagram, or the cause and effect, or the fishbone diagram. And that helps you brainstorm different causes that might potentially be generating the effects that you don't want. So that's one tool that you use. Then the flow chart is like this. This is not the best flow chart, but it shows you the flow of the processes, and it shows you what's done in series or in parallel, and it has different shapes for different kinds of activities. What this one doesn't show is that often, so the round circle is usually a process step. The square is a process step. There's a data kind of symbol that you use. There's also a diamond that you use, which is always the question mark. So it says, is it good or is it bad? So if you're checking something, testing it, then you say, if it passes, then it goes this way. And if it doesn't pass, it goes another way. So it documents the flow of the process, indicates the sequence, and you can put times on that. If you want to make it more of a project chart, you can say that the circles are for people and the squares are for machines or some different types of things to define what those steps are. But that's a flow chart. So hopefully you've seen some of those in different ways, but that's what that is. Then the checklist is what we talked about before. So here's our defect type. This case, we're looking at fabrics, how many broken zippers, how much ripped material, missing buttons, faded color. So we just make a check every time we see that. We're checking this pile of goods, and every time we see one of those issues, we just make another check. And you'll see it with lines or check marks or whatever makes sense. And then the control chart we looked at, these are the things that we actually graph over time. Here's the statistical process control chart, again, with the 99.7% with the 3 sigmas on each side of the mean. And then if we get out to the 6 sigma, we're at the 3.4 opportunities per million, which that's a number that's a good one to put on the test, right? What is 6 sigma equal in terms of defects? And then give you some change. Like I said, the test is going to be multiple choice because honestly, that's the easiest to grade. So here's the 6 sigma again, and then here's the control chart. So this control chart is a little bit better because this one has our mean value. It shows the values that we plotted. Here's the control limits that we calculate from the data that we actually collect. And then the specification limits, which are given to us as the upper and lower boundaries of what is acceptable. So we have to know where the specification limits are, and we want the control charts within that specification. Sometimes, like I say, you can have a really nice chart that has the control. It's in control, everything's looking good, but it's skewed so that it's not inside the spec. So then you have to move that mean somehow and get it to where it's inside the spec limits. You all understand the difference between the control limits and the spec limits? Anybody confused about that?
Could you explain the difference?
The specification limits are defined by the, I'll say by the engineering, by what the product is supposed to do. So that's given to the production people. Then the control limits are actually calculated from the actual values of the results that you're doing in the process. Does that help, Peter?
Yeah.
So if I'm a production manager, I'm going to be given specification limits that say, Jane, go make parts, and your parts need to be within this level of specification. Here's your high value, here's your low value. It has to be in between there. Anything that you make in between that range is going to be acceptable. So that's what they tell me I need to do. So now I go make a process that says I'm going to make parts time after time after time. So then I'm going to calculate my control limits, and I just got to make sure that my mean is centered such that my control limits are inside my specification limits. Otherwise, I can have something that's in control, but if it's too high, the mean is too high, my average is too high, then I might be outside my spec limits, and my process is doing a good thing, but it's not making parts that are going to fit with everything that everybody else is making in the factory. So I have to change it. I have to make a process adjustment to get that mean back in where it needs to be. And that's the last slide. So any questions about that? Hopefully these tools and these charts kind of make sense. Checklist should be familiar. Control charts, I don't know where you took your statistics class, but I don't think they teach enough of that in statistics, and they surely should. Flowcharts are fairly common to document processes. This one is a brainstorming technique, so you might not have seen the cause and effect or the Ishikawa before, but it's a good tool. So that's all I have tonight. If you have questions, I'm happy to take questions. I'm going to stop the